Please take a moment and read through problem number 3. I think the first thing we need to do is draw in this rectangle. Well, if I'm bounded by the parabola and the x-axis, maybe it looks something sort of like this. And I can put a point over here at that corner of the rectangle, and I can call that point x comma y. I want to maximize the area of this rectangle. Well, if this point is x comma y, I know that the height of my rectangle is y. I also know that this over here is x. Well, if that's x, and my parabola is symmetric, I know that this is also x, so I think the entire base of my parabola will be 2x, and my area will be 2xy. For a secondary equation, I need some way to relate x and y. Do you have any ideas? I need to go and use that formula for the parabola. For any point on the parabola, which will be a vertex of my rectangle, I know that y equals 36 minus x squared. So I can say y equals 36 minus x squared is my secondary equation. We're going to take that and we're going to plug it in for y. We're going to get a equals 2x times 36 minus x squared. So my area is 72x minus 2x to the third. Can you take a moment, find the derivative, and find the critical value or values? We should be getting plus or minus the square root of 12, and I think I'm just going to, do I want to leave it that like that? No, I think I'm going to simplify it down to plus or minus 2 root 3. And I realize that x is a coordinate there, but if I'm also considering it to be a distance, it should probably be a positive distance, so we're just going to focus on 2 root 3. Now, probably should have done my domain earlier. I know that x, since again, it's also a kind of a distance over there, x can't be something negative, so I'm going to say 0 is less than or equal to x. But at the same time, x cannot be more than, well, whatever this point is over here. Because if this is the base of our rectangle, we wouldn't have any room left to be able to get a height in there. Can you figure out what that point is, where our x-intercept of the parabola is? Well, to find the x-intercepts of our parabola, we could just set our parabola equation equal to 0. We're going to get x squared equals 36, x equals plus or minus 6. In this case, x is going to equal 6, which means my domain is 0 less than or equal to x, less than or equal to 6, and we can use the candidates test. So I'm going to label my columns x and a of x, and I need to use the endpoints 0, the critical value 2 root 3, and 6. We're going to go and plug into our area formula. 2 times 0 equals 0. Oh, you know what? I probably shouldn't be doing that. I should probably be plugging into my version that's just an x over there. And it was wrong. It's y is not going to be 0, but okay, you know what? I don't like this. We're going to try this again as soon as I can get my whiteout working. Oh, good. Sorry, I just don't feel like re-recording this video. Bear with me. There we go. We're going to go and we're going to plug in 0 to our area formula that just has x's in it. Either this version, which actually might be a little bit easier, or this version. I think I'm going to use this one over there. I've got 2 times 0 times 36 minus 0. 2 times 0 times 36. That's 0, as it should be. The 2 root 3, well, 2 times 2 root 3 times 36 minus, you know what, instead of 2 root 3 here, how about I do square root of 12? which I'm going to square. That gives me 4 root 3 times 36 minus 12. 4 root 3 times 24, I believe, should be 96 root 3. Plug in your 6, you're going to get 2 times 6 times 36 minus 6 squared. I know that's going to be 0. So I want to find the dimensions of the rectangle. My dimensions are going to be, well, remember the rectangle is like 2x by y. I think that means, well, first, we have a maximum over there. The dimensions are going to be 2 times 2 root 3 by, what's y? Well, 36 minus root 12 squared. That's going to give us 4 root 3 by 24 for the dimensions. As for the area, we already figured that out. The area is 96 root 3.